You just very briefly touched on an element that you said was missing from the school experience of experiencing science and religion, and that's a philosophy of science. And I think it's a really interesting observation. I think it's actually quite key. How does the philosophy of science help us to have a deeper understanding of what's actually going on in science, rather than just sort of a objective, factual, disinterested, neutral enterprise? That there are actually suppositions and assumptions, philosophers would say, that are built into this very project, which are important to know about, I would argue. So what is the philosophy of science, and how does it help us to understand these issues better, do you think?
Yeah, so I suppose there are different ideas about what the philosophy of science is. Popper's interpretation is probably the one that's kind of taught in universities most frequently now. And it's the idea that a scientific statement or fact is one that should be inherently falsifiable. Yeah. So you should be able to disprove it in and of its nature. So science, in that sense, there's this kind of idea of paradigms in which under a certain umbrella, a lot of things make sense and fit within a model.
Right.
But there are slight anomalies within that model, things you can't describe, things that don't quite fit the model perfectly.
Right.
And then over time, a development of a new model or an adaptation of the previous model can then encompass more of the things that we weren't able to describe previously. And so this kind of scientific progress, you could say, in how accurately we can model things, particularly in physics, is what science is about. I would say a high-level physicist is very much aware, and you must be aware of in fact, in every exam you take, you have to always state your assumptions. So it could be the conservation of energy or the conservation of linear momentum. And you essentially, it's very interesting, but you use the model that gets you the accuracy of answer that you need for what you're doing. So you never try and use a more sophisticated model than you actually need to for your description.
So parsimony, this idea of economy of knowledge is key. And I mean, there's a very famous text, of course, by Thomas Kuhn called The Structure of Scientific Revolutions. He's a Chicago professor, which gave the theoretical explanation of paradigm shifts. So how, obviously the famous ones are the Newtonian paradigm shift, where we had a mechanistic universe of discrete blocks and like billiard balls bouncing off each other, and objective laws of physics and so on. And then we had Einstein come along beginning of the 20th century with his general theory of relativity, and everything became very different with probability waves and so on. And so that's one example of a paradigm shift that is obviously the most famous one, I suppose. But you're talking about even in exams, even at Oxford, you have to state your models, your assumptions, your working models before you go ahead and do what you do in the exam. But so you're not just going straight in. You have to say, these are my assumptions. I think that's really interesting.
Yeah, absolutely. And they're inherent. And you must state them. Otherwise, your answer, if your foundations aren't strong, then no one believes in the structure you create, which is essentially how scientific models work. And you can go further back from physics, because essentially all physics is based in mathematics or described using mathematics. Right. And mathematics really isn't science. It's a branch of logic. It's a type of philosophy, in the sense that science is also a natural philosophy, but it's become so removed from philosophy, we almost see it as separate. I think mathematics is still, you can see a little bit of really fundamental philosophy in there, in mathematical ideas. And actually, one thing I would say is, in the West, the kind of divergence we see between religion or faith, as the term is used, and science, historically wasn't there. You mentioned Isaac Newton. He was, although not a traditional Christian, he had a conception of the idea of God. He was a deist in that sense, and so was Einstein, and famous people like Lemaitre, who was a very famous cosmologist. These people had a very firm idea of the existence of God, and they were also philosophers. I think the kind of specialization of knowledge, we don't really get polymaths anymore in that sense. The specialization of knowledge being a very modern phenomena, this kind of splintering of knowledges has led people to perhaps have a very narrow view of their kind of field being the independent from other forms of knowledge, that false independence they perceive, where they don't really understand the assumptions they're working with, is one of the issues I've observed.